Hi to all, this is A. Oble, Assistant Professor, Department of Computer Science, Engineering, Mundra Group of Institutions at Anand, Hyderabad. These are the basic slides for understanding inter-process communication. In inter-process communication, first of all, we'll discuss about how many types of processes. There are two types of processes. First one is the independent process. Second one is the cooperating process. Independent process is a process that cannot affect another process execution. That means a process which cannot affect another process execution. Otherwise, the process which does not affected by another process execution. In this sense, we can call the process A as independent process. Cooperating process. Cooperating process can affect or be affected by another process, including sharing data. That means the process should affect by other. That is what cooperating process. Why we need inter-process communication? First benefit what we are getting is information sharing. By cooperation of the process communication, here we are getting what information sharing means. One process data should be shared by another process. So no need to create again and again. For example, a process creates child process. Child process no need to create the functions whatever that is defined in parent process. Just you can share it. So your parent process can communicate with its child processes. By its communication, the parent process can share a lot of data. That's what I call it as information sharing. Computation speed up. So, by the communication of inter-process communication, you can compute the task in efficient manner, in very fast manner. Modularity. If we want to design a system in modular wise, we need inter-process communication. Convenience. For user convenience point of view, the inter-process communication is required. Cooperating process needs inter-process communication. So these are the benefits of inter-process communication. Now, there are two models in I2C, that is a shared memory, and second one is a message passing. First one is a shared memory. As in case of shared memory, one process can create shared memory area and remaining processes can be shared that memory. Means here, process A created one shared memory segment. Whenever the process B wants to share that data, first of all the process B makes a request for process A. At that time, the process A gives the address of shared memory. At that time, the process B will go for that shared memory and it can share the data. This scenario what I call it as shared memory. Here, one of the good example of shared memory is a producer-consumer problem. Here, the producer is a process which is always producing data items. Consumer is a process which is always consuming the data item produced by the producer. For example, client and server. Here, the client always generating web pages. That web pages are consumed by client. Here, the server is a producer process. Client is a consumer process. And a very good example is the father and son. Father is earning the money, son is always consuming the money. This is what exactly the examples of producer and consumer. So in between producer and consumer, it will use a buffer. This buffer may have in two forms. One is a unbounded and another one is a bounded buffer. Unbounded buffer places no practical limit on size of the buffer, means that there is no size of the buffer That's not what we are calling as unbuffered buffer. If there is a fixed buffer size, then we are calling it as a buffered buffer, bounded buffer. One of the solution here, I am giving some code for it. There is a structure for shared memory. This is a structure. The buffer size is a 10, and buffer is one of the array here. What I consider in and out is a 2 pointers. Here, in always pointing to next free location, and out is always pointing to next filled location. These are the 2 pointers which are pointing to buffer. Here there is a produced code. In value initial is 1, 0, 0 plus 1, 1 modular division by buffer is 10, 1 modular division by 10 is 1, right? 1 equal to out, no, the condition is false. Whenever the buffer is full, the producer stops the producing of data items. Right here, 0 plus 1, 1 modular division by 10, that is not equal to out, that's why you go for that. Next produced item will be stored in buffer 1. Next here, 1 plus 1, 2, 2 modular division by 10, that is the remainder is the 2 will be stored in. Again it will repeat, while loop will be repeat here. So here, just the while loop will be repeated like this until it becomes 10. If 10 equals 10, then buffer is full. At the time the producer will stop the producing of that item. This is a consumer process. Consumer, if there is no data in buffer, no need to check. For checking purpose, here we are using one condition, that the in equal to out. If in equal to out means the buffer is free, no data item is there. That's why do nothing. If there is a data item, then buffer of out that will be stored in consumer. So in this way, producer and consumer will be synchronized each other. Message passing. Yeah. Message passing means that one process can communicate with another process. Here, the mechanism for a process to communicate and synchronize their actions. Message passing system, process communicate with each other without resorting to shared variables. There are two system calls that will be used in communication. That is send and receive. Send is a message. Send is a system call that can be used for sending the message. Receive is another system call that can be used for receiving the message. Send a comma message means here the message is sending a. The message is sending a. The message is sending to